Okay, everyone, the last assignment in the unit, isn't that great? And this is homework 10, and we're going to look at ways to calculate the area of a triangle. We already know the one that we've used throughout the whole course so far. The area of a triangle is equal to 1/2 times the base times the height. But what if you don't have all that information? You need to have an alternative way to calculate the area of a triangle. Or what if you have the base and what if you have all three sides of the triangle? There's a way to calculate an area with that. If you have two sides and the included angle, we can calculate the area. So this is what we're going to look at as we look at this. We have triangles come in all kinds of shapes. We have right triangles where one of these would be the base and the other one would be the height. And this one's easy to do with your 1/2 base times height. We also have triangles like this. And this is fine if they've given you the height and the base. Then it's easy to use that. But they don't always do it that way. You have triangles that look like this. And we have triangles that look like this, which is really a weird one. And if you're going to do base times height, you have to expand a few things to make it possible. So you see, with different shaped triangles and having different things given, it's kind of nice to have more than one way to calculate the area of a triangle. So in this lesson, that is exactly what you're going to find out. We're going to find two more ways to calculate the area of the triangle. Your first way that you've been doing up until now is 1/2 times the base times the height. And we're going to finish this lesson by looking at three different triangles with different information given, and you have to decide which is the best way to go about calculating the area of the triangle. So let's look at what we can do with these. The first one uses trigonometry, and that's what we did in our last lesson. So this will be an extension of that. If you know the measure of two sides and the angle between those two sides. In other words, side, angle, side. Remember that from similar triangles? We could prove triangles were similar if the two sides on either side of the angle were proportional and the angle in between those two sides were equal. So this is what we're going to do. The area of this triangle will be 1/2 times A times B times the sine of the angle C. So let's look at that. Let's look at a couple examples of that. We don't even need the third side of these. Okay, this is angle C, this is side A, and side B. If side A is equal to 10 inches, and side B is equal to 14 inches, and my angle in between is 45 degrees. Okay, here it is. 1/2 times my A, which is 10, times my B, which is 14, times the sine of that angle, which is 45 degrees. So what does that equal? Well, let's see. 1/2 times 10 times 14 is going to be 70, and so 70 times the sine of 45 is equal to 35 square root of 2, which is completely, totally accurate. The approximation would be 49.497 degrees. If you rounding to the nearest degree, it would be 49 degrees. If it's the nearest tenth, it would be 49.5 degrees. So it just depends upon what the rounding is they ask for. Okay? Oh, that's not degrees. That's inches squared. Remember, we're getting area of this triangle. I've got degrees on my mind. Okay? We're looking at that. Let's look at another example of this. Because we're looking at area. Okay? Let's look at this one. .5 degrees. A is equal to 8 feet and B is equal to 22 feet. What would be the area of that triangle? Again, 1/2 times 8 times 22 times the sine of 55 degrees is going to equal feet squared. Okay? Square feet. Okay. 4 times 22 would be 88. Sine 55. 72.08. So 72 square feet. Let's do one more. Okay? As you see, these are actually not hard to do, but you needed that trig to be able to do this. Okay? Let's look at this one. 8 meters. Oh, that one's close to the same. 8 meters. And 110 degrees. Okay? Again, we have the side, the angle, and the side, so we can use our trig formula here of 1/2 times 8 times 8 times the sine of 110 degrees. So that will be 32 sine 110 degrees equals to 30.07. So if they want a whole number, it's going to be 30 meters squared. Or if they want round to the tenth, it would be 30.1 meters squared. So your rounding is important on this. Okay, that's the end of the trig formula. Now let's look at the second method we're going to look at. This one is used, it's called Heron's formula. And Heron's formula is used when you know the 3 sides, but you do not know the height. So Heron's theorem. And it gives us a formula. Know all 3 sides. Don't know height or angles. Okay, so that's what we need to know. We need to know the 3 sides of the triangle. And so here's our formula for the area with Heron's formula. It is area is equal to the square root of S times S minus A times S minus B times S minus C. Okay, it's a formula. Now, we need to know what S is to use this. And S is the sum. S is the sum of the 3 sides divided by 2. So S equals A plus B plus C and divided by 2. So let's look at a triangle. Here's an example. 5 centimeters, 8 centimeters, and 9 centimeters. We have no idea what the height is. We have no idea what the angles are. So the first thing we have to do is calculate our S. So S is equal to, this is A, B, and C. So 5 plus 8 plus 9 over 2. Okay, that's 1422 divided by 2 equals 11. So we know our S. Now, let's find the area. So the area is equal to the square root of S, which is 11, times 11 minus 5, which is A, times 11 minus 8, which is B, and 11 minus 9, which is C. Okay, so area equals the square root 11 times 11 minus 5, which is 6, times 11 minus 8, which is 3, times 11 minus 9, which is 2. And that's equal to the square root of 11 times 36 equals to the square root of 396. And the square root of 396 is equal to exactly 6 square root of 11, approximately equal to 19.9 centimeters squared. Okay, so there's one example. Now, let's look at a second example of this. In some ways, I think this is easier than some of the other methods we have used. Okay, so let's look at another one. I have an isosceles triangle, and these are 10 meters, 10 meters, and 6 meters. Now let's look. First of all, our S is equal to 10 plus 10 plus 6 divided by 2. And that's 26 divided by 2, which equals 13. Okay, now my area equal to the square root 13 times 13 minus 10 times 13 minus 10 times 13 minus 6. So my area is equal to my square root 13 times 3 times 3 times 7. And that is equal to 3 square root of 91, because there's 2 3's here, so that's my perfect square. And your calculator can give that to you too, or approximately equal to 28.6 meters squared. So you see, calculating the area this way is actually not hard at all. It just comes together really nicely. Now let's look at 3 triangles and let's decide which way you're going to use to calculate the area of these triangles. All right, so let's look at that. Here's my 3 triangles. inches, 8 inches, and 14 inches on that triangle. And my last triangle is this one. 20 feet, 18 feet, and a 35-degree angle. Okay, looking at these three triangles, how would you calculate the first one? Well, first of all, let's analyze. I have a base and I have a height. So this is going to be the first method that you've done a lot. A is equal to 1/2 base times height. So my area is equal to 1/2 times 15 times 8, which is equal to 60 centimeters squared. Okay? So you see that one. I had a height and a base. So it makes sense to use the very first one we knew. Look at our second one. We have all three sides are known. So this is going to use Heron's formula. So my S is equal to 11 plus 14 plus 8 divided by 2. And this is going to give me equal to, let's see, 25 plus 8 is 33 divided by 2. And that's going to be 6.5. So this is 16.5. So now my area, 16.5 times 16.5 minus 11, 16.5 minus 8, and 16.5 minus 14. This gives me now 16.5 times, that will be 5.5, 8.5, and 2.5. Oh, did I miss to add that? Oh, no, I did it wrong on my paper. I had 15 instead of 14. I made a mistake on the paper. Okay, so now we need to multiply all those numbers together. And on your calculator, you can put in your square root sign and just type everything in under that square root. And it gives you a shortcut. 8.5 times 2.5 equals. And this is approximately equal to 43.91. In other words, 44 inches squared if we round it to the nearest whole number. Okay. So, that's the third one. The second one. Now the third one. That's going to use our trig formula, which remember is my area is equal to 1/2 A times B times the sine of my angle C. This is A, C, and B. Okay? So A is equal to 1/2 times 18 times 20 times the sine of 35 degrees. Let's see, 9 times 20 is going to be 180. Sine 35 degrees. And let's see what that gives us. 180 times sine 35 gives me area is equal to 103.24 inches feet squared. Be sure to look at what your unit of measure is, or if they want the closest whole number, 103 square feet. So there you go. You have 3 different methods now for calculating the area, and that's it. It's not too hard. What are you given? Base times height. Use your first method that we've used all semester long. If we're given 3 sides, use this new Heron's formula, which we have here. And so I'm going to write my S again. A plus B plus C divided by 2 is your S, and your area is equal to the square root of S times S minus A times S minus B times S minus C. So there you are. Two formulas which are not too hard to do, and you can find the area of that triangle. And then our last one is using our trigonometry, because we don't even know the third side. We know the two sides with the angle in between, and we can use the trig formula, which is area is equal to 1/2 times A times B times the sine of C. Okay, everyone, enjoy! Last lesson. It's wonderful. Okay, bye-bye.